We're going to move on to the next talk of the session, which is Francisco. It's going to tell us about ALeRCE.
Hi.
Hey.
Can I share now?
Yes, please share now. Yeah.
Can you see my screen?
Yes, we can.
Okay.
Great.
So, thank you, everyone. So this is the last talk of the session. I will talk about the ALeRCE broker, which is a very large collaboration led from Chile, but also with many institutions in Chile, but also in some in the US. We have put in the archive our first 3 papers, and you can visit our website for more information. So ALeRCE is a Chilean-led initiative to build a community broker for LSST and other large SNU survey telescopes. ALeRCE is also a tree that you can see in the background. It's very similar to the redwoods in California. So the scientific aim of ALeRCE is basically very diverse. As we are growing in science cases. So we have transients, variable stars, AGNs, asteroids. We have a very strong group on AGN, I think. And something very important for us is that we are use case driven, and also we use agile methodologies. So we believe that although brokers is a very challenging technical problem, it's really a people's problem. It's finding what people need, what the community needs, and so we really need use cases. In order to classify different objects, we need a taxonomy. So this is the simplified taxonomy that we are starting, following this agile methodologies. We start with something simple, and we have these 15 classes. And the idea is that with time, these classes will start growing, and this hierarchical classifier will start going into more detail into the different branches. The status of the project, we have been online since March of 2019. So we have gained a lot of experience from CDF. So we're really happy to have received these alerts from CDF. We have 2 classifiers that are working now in production. A stamp classifier that is based on the images of the alerts, the first image of the alert, and the light curve classifier that is based on the light curve as alerts arrive and you get more information of the given object. Under development, we have a blind classifier that is beta testing now, a multi-stamp classifier, and also we are incorporating CTF data release 3. So here on the left, you can see the confusion matrices of our stamp classifier that is based on a simple taxonomy: AGN, supernova, variable star, asteroid, and bogus. So because you have only the spatial information, there's not much you can do, but works surprisingly well with these classes. And then on the right-hand side, you can see the light curve classifier confusion matrix, where you see all the 15 classes. And as we get more training sets and better models, these confusion matrices are getting better and better. So each of these have its own paper. So we have 2 main wave interfaces, the Explorer and the Supernova Hunter. The Explorer is basically to explore the light curves, the repository, the stamps, the classifications of the different machine classifiers. And the Supernova Hunter allows you to find very young supernova, the latest young supernova candidates. Using the Supernova Hunter, we have submitted more than 4,000 supernova candidates to TNS, of which about 600 have been spectroscopically classified by other groups. So if you want to have access to our output stream, you can contact us. And also we are developing experimental watch lists. So here's a list of the classes that have been spectroscopically classified. In terms of stream, we are inputting the full CTF stream, and we are working to implement the ATLAS stream, which is a network of telescopes in Hawaii and soon in South Africa and Chile, and of course the LSST full stream. We also want to include other kind of alerts, and we are working to in next year start perhaps including other. Sorry. Then in terms of other catalogs, we're using, of course, Gaia, PS1 that are included in the CDF stream, but all WISE have been very important for us. We're also working to include CDF data release 3. And if you want more catalogs, please contact us. For in the future, we plan to provide the free full LSST stream if you're in the cloud, because we're based on Amazon, and we are now evaluating the cost of doing this from our own on-premises infrastructure for other users. And of course, this will be open if it's based on public data. Our pipeline is based on this alert processing framework, which is all based on Kafka, where you have different steps that are Dockerized and all is managed via Kubernetes. So as the alert arrives, it's saved in Amazon, and then in parallel is cross-matched with public catalogs, then goes through stamp classifier and different steps for the Lightcode classifier, including outlier detection. And this is what we output in the output stream. So as I mentioned before, we have two main web interfaces. I think everyone is adopting this kind of interfaces now. So the Explorer, where you can see the Lightcode stamps, machine learning classifications, etc., and the Supernova Hunter. How to access ALeRCE? Through the web interfaces, through our APIs, that we have taken a lot of effort doing that, and also many Jupyter notebooks. We have put a lot of effort in building Jupyter notebooks in collaboration with our community of users. And of course, the output stream. In the future, we plan to do data releases of the machine learning classified catalogs, and of course, the outlier service that we are developing. In terms of the database, we are working with PostgreSQL, but we are experimenting with Cassandra or other NoSQL databases. We have a very user-friendly API documentation, and we have version control for training sets, for the classifier, and all the pipeline steps are Dockerized. Something I didn't mention is that if you want to add a step to this pipeline, it's very easy. You just give us the Docker container, and we implement it. And also, as I said, the Python-based client allows you to integrate very easily with the notebooks. And we have been doing tutorials based on the cloud, and it had worked really, really well. The database is organized in this way. So first, the data that is not aggregated, the data that is aggregated in time, and the data that is aggregated in time and in filters. So for example, here we have features that characterize the Lightcode objects. The user community. So first, we have all these notebooks available for the community. If we use Google Analytics, we have seen more than 50 countries using our system and more than 2,000 users. And this is a list of the countries with the most users. We recently organized a tutorial. It was very, very successful. We had more than 150 participants. And we have all these talks online, more than 6 hours of recording. In terms of collaboration, of course, we're helping to organize this workshop. We are collaborating with Think to design benchmarks, but we would like to include other brokers as well. And something very important for us is that we believe that we should favor a diverse ecosystem. So there's a tendency in technological kind of initiatives to have this winner takes all. And I believe we should avoid this in the community. Otherwise, we will end up with a big, slow broker. So in terms of benchmarks, we have thought about alerts processed per second, database ingestions, queries per second, classification confusion matrices, and balanced classification metrics. I think we can get help from the science collaborations here, and the capability to do big queries, the capability to add new pipeline steps or filters. So here you can see the cumulative distribution function of the different steps in the pipeline. So it's only 1 second really to have your alert ready. We are testing also Cassandra, as I mentioned before, and we have reached the levels of reads and writes that are good enough for LSSTC. I also mentioned before that we are trying to integrate Atlas. We're also collaborating with LSSTC in this respect. For example, here you can see a light curve that was built with Atlas and CDF. And so you can see that they're really complementary. And you can see the astronaut that we published recently. We're connected to the DOM. We have a custom frontend, and we have submitted more than 600 observations already. So just to finalize, this is a summary. We have the stamp classifier, the Lightcode classifier with all this taxonomy that is going to be growing with time, the Supernova Hunter, the Explorer. We have a diverse team with many institutions and really experts in machine learning, in astronomy, in fully dedicated data engineers. We have many users around the world. We have a modular pipeline, and many notebooks that we have put a lot of effort in building. So please visit our website here. Thank you.
Thank you, Francisco. A question for Francisco.
Yeah, I've got a question on Zoom. Out of the 2,000 plus users, do you know how many are repeat users?
Yeah, that's a good question. I don't know the answer. So Google Analytics, what it does is count the unique combinations of IP address and device. So they could be repeated users. Yeah, I don't know the answer to that.
We could do one more question for Francisco if there is one.
Well, I have one. There are no others there. It looked in your slide where you were uploading the alerts to S3 to Amazon, that you were uploading the alerts and then you were doing the annotations and cross matching elsewhere. Is that just the way the slide was presented, or is that true?
No, that's true, because we store the alert and we keep the alert in memory and continue working with that alert. So
okay,
yeah.
And then what do you do with the annotations once you've built the annotations? You then send them back to S3 for storage, or?
No, we store it in the database in Postgres. So this is like it's like a backup for future analysis. So all the main contents of the light curve, so all the tables that I presented are populated in this bottom branch. Yeah.
Understood.
Yeah, and also the fact of being in the cloud allows you to do like very massive calculations very quickly. So in 1 hour you can reprocess all the CDF alerts. So this is one of the advantages that we have found.
Great. Thanks very much, Francisco.